Hello, today I have a set of power adapters for one video. This is a Patreon request. Here I have a 45 watt and a 65 watt TECKNET power adapters. These are all wall adapters filling the mid-range of power bricks. In this series, I try to answer the question, which power adapter do I want to get? The videos get technical, so hang on and always ask questions if you don't understand something. The performance is measured and compared to near competitors to see how each one stacks up. If you want to help out the channel, see the links on my webpage or in the description. Patreon is now live as well as the super button, thanks to my current patrons. Let's open these adapters up. They come in these bare minimum paper boxes. These are very easy to open, and at least, to no one's surprise, the power adapter takes up most of the space in the box. Not bad. I like the bare minimum approach here. Taking a look at the power adapter, the 45 watt doesn't look too bad. Outward quality wise, they don't seem too bad. I'm getting my hopes up. Is that a bad idea? I think it's a bad idea. We'll find out soon enough. It looks like both of these power adapters have safety listings. They don't share the same listing though. One of the power adapters has an ETL listing while the other uses TUV. I wonder if these adapters are also rebranded under some other brands. They seemed unique to me though. The power adapters come with an option to extend the warranty to 3 years. The user manual for these adapters are very comprehensive. They give a little blurb about why GaN is better. I don't think anyone really knows why faster is better, but marketers be marketing. The manual show the various modes and rough performance specifications for each, but don't mention PPS. These often don't though. We'll have to investigate this further. The packaging for the 45 watt power adapter weighs 11 grams, very light. The power adapter weighs 105 grams. The packaging for the 65 watt adapter weighs 12 grams, also very light. The 65 watt power adapter weighs 106 grams, almost the same as the 45 watt. The weight for the 65 watt is not bad. In terms of size, these are different shapes to a lot of other adapters. The Anchor and Aohi offerings are more cube-like. The 45 watt adapter has some decent looking features on paper. This adapter also has quite a lot to offer for voltage modes to power many types of devices. The USB power delivery modes fixed output voltages are 5, 9, 12, 15, and 20 volts. This device also has PPS modes or variable output voltage modes. Your device selects which one of these modes is most appropriate for charging. This device supports a 6 or 11 volt mode with 2 cables plugged in, or a 16 volt mode with 1 cable plugged in. This should be able to charge anything from a watch to a laptop. The 11 volt PPS on 2 ports will charge one device at 25 watts and the other one at 20 watts, so this isn't bad. The 16 volt mode can do the full 45 watts on PPS, so Samsung devices should be happy. The 65 watt adapter scales things up in terms of power output, but it looks like it has less features. This adapter offers the same fixed output voltage modes, but only offers an 11 volt PPS variable output voltage mode on 1 port at a time. The PPS mode tops out at 32 watts. Why does the 45 watt do more? Both the 45 watt and the 65 watt adapters are missing something, and it looks like all the adapters in this class seem to not bother with power factor correction. Power factor correction is a technique to consume AC power as efficiently as possible. The higher the power factor, the lower the comparable current, and therefore the lower the loss in wires and transformers that supply your power. At this power level, I guess it is deemed unnecessary, but I would still like to see someone make an adapter with this. The 45 watt adapter does have an LED to indicate that it is powered. Once plugged in, the 45 watt adapter has issues with its power at idle. The adapter uses far too much idle power for a small adapter at 0.2 plus watts. This doesn't meet the DOE 6 efficiency requirements and is a total fail. The device shows promise with its feature set, but the power performance is turning bad. The 45 watt adapter does deliver the full rated power without any problems. The adapter does renegotiate for any plug or unplug of the USB ports. As we already saw, it doesn't have power factor correction, which isn't a surprise at 45 watts. Let's take this one up to overload and see how it does. Overload is testing when the device safely shuts down when too much power is drawn. It looks like this one tripped at 51 watts, which is a safe limit. It looks like it recovers to 5 volts, so the cable doesn't have to be unplugged. So while on the 45 watt subject, let's do a quick comparison with other 45 watt adapters. It is probably no surprise, but this one is faring the worst. Highest idle power consumption and worst active power. We have to see if the cost is just so low that it can still save you money. The 65 watt adapter is a little better than the other one. Still on the high side for idle power, but it met the DOE 6 efficiency requirements at least. This device can easily tolerate the 65 watts at full load, and after running for a half hour, the casing of the power adapter did get quite hot, over 70 degrees Celsius in spots. This is still considered acceptable, but it is shocking to grab something that's that hot. The power adapter does renegotiate USB voltage on any plug or unplug of ports. Let's see how much this power adapter can get to before it trips on overload. 65 watts is not a problem, but by 72 watts, this power adapter trips on overload. This is also a safe overload level, so not bad. The power adapter also recovers after an overload condition without requiring the power cable to be unplugged and plugged back in. The devices all stay within the basic requirements of the USB power delivery specification for DC output voltages, so another positive. The data for this 45 watt adapter shows that it has some issues. The THD in all modes is high, but not the worst I've seen, so some effort was used but not enough to make it a clean power supply. The efficiency and power quality are also far from leading. I am not seeing a ton of performance here. The 65 watt improves the efficiency a little bit, but it also has some line filtering in place, so the THD at low level and idle are very low levels, which looks reasonable. No power factor to be seen here. At least there are some reasons why this adapter doesn't seem that bad. In comparison with other power adapters, these adapters aren't so great. We already saw the 45 watt adapter took the bottom of the chart. The 65 watt power adapters tend to be clustered fairly close, and no surprise this is one of the lower performers. The Amazon adapters still top the chart here. I have a newer 68 one. This is a secret squirrel data since the review isn't out yet. Also, there isn't much range to these, so they could all be better. On the idle graph, these adapters are not great. They use the most power, and one doesn't meet the energy efficiency requirements, and one does barely. The quality is also lower than the competition. On the average power consumption graph, the AC power quality of these devices starts to show. The power performance, the thing that I would argue is most important in your power adapter, is not great. They do what they need to do, but the high current flowing in the device means that more heat, more loss, and that ends up with lower efficiency. Roughly translated, that means higher operating cost. Final notes. These power adapters are not class leaders. These power adapters have a lot of the boxes checked on paper, but upon a deeper dive, we find that they are inexpensive and can offer that price point for a reason. The 45 watt adapter is only $26, so it is a really inexpensive option and does offer quite a lot of charging modes. It doesn't offer great efficiency though, and suffers from high idle power consumption by not meeting the DOE energy efficiency requirements. This also wouldn't meet the EU requirements. The 65 watt adapter is a little more expensive, but that doesn't make it make sense. It is a $36 power adapter, which again isn't bad for the power level, but this power adapter strips away features versus the 45 watt adapter. Both of the power adapters have safety listings, which is a positive. The 65 watt adapter did get quite hot while charging at full load though. No power factor correction to be found here or anywhere at this power level. The AC power and DC power stay within reasonable limits, and the devices tolerate overload safely. We can see that the build quality doesn't look bad on the outside, but what's on the inside is definitely being built down to that price point. I can say with confidence that I won't be using either of these power adapters as my daily drivers, but if one looks like it's what you need, there'll be links down in the description. As usual, time to apply the stickers. These mostly let me know that I tested these things. Next week, the plan is to test some bigger power adapters, the Ugreen versus Watobius 200 watt battle. I have many more of these power adapters to get through and many more videos in the future. Thanks for watching, and bye for now.